Welcome back to Chemistry Matters and our unit on solutions, acids, and bases. Chemists often create and work with solutions. Some solutions have a lot of solute in them. A qualitative way of describing such a solution is to say it's concentrated, like this concentrated orange juice. A qualitative way of describing a solution that does not have a lot of solute in it is to say that it's dilute, like the orange juice that I'm making. However, it's not practical or safe to always use these qualitative descriptions of solutions. We need measured or quantitative descriptions of our solutions. There are many ways that we can describe a solution's concentration, but in this unit, we're going to focus on three: mass percent, molarity, and molality. So let's head back to our classroom, where our students are exploring different ways to express solution concentration.
Let's look at three ways of describing a solution's concentration, starting with mass percent. Mass percent is a simple way of expressing how concentrated a solution is. It's found by taking the mass of the solute in the solution and dividing it by the total mass of the solution and then multiplying it by 100. One thing to keep in mind when calculating mass percent is that it's the mass of the entire solution, not just the solvent in the denominator. So to determine the denominator, you have to add the mass of the solute to the mass of the solvent before you can find the mass of the solution. It'll help you understand if we practice. What would be the mass percent of an aqueous solution of salt water if you place 1 gram of salt into 99 grams of water? Use the formula to figure out the answer.
It would be 1%.
That's correct. How did you get that?
Well, since the mass of the solute is 1 gram, that would go into the numerator. So 100 grams would have to go into the denominator. Since that's the total mass of the solution, then divide and you get 0.01. So I just multiplied 0.01 times 100 to convert it to a percentage, and that is 1%.
Very good. And to create a solution with a specific mass percent, the only equipment you really need is a balance of some sort, and of course the solute and the solvent that you plan to use. Can anyone think of an example of something like this?
My little brother had poison ivy a few weeks ago, and he used hydrocortisone cream on it. The cream had 1% on the label. Is that what you mean?
That's exactly what I mean. So the active ingredient, hydrocortisone, was only 1% of the cream. Good example. Now, the next way to express how concentrated a solution is, and by far the gold standard for chemists around the world, is known as molarity. Molarity is the ratio of moles of solute to the volume of the solution in liters. It's calculated by dividing the moles of solute in the numerator by the volume of the solution in liters in the denominator. Molarity is abbreviated with a capital M. A key point to notice here is the use of liters in the denominator. Since we want to measure the volume of the entire solution, special glassware is used to create solutions of known molarities. A volumetric flask, like the one I'm holding, will allow you to put the number of moles of the solute in the flask first, then add distilled water up to the line. So now what I'd like for you guys to do is to create your own solutions of known molarity. Team 1 should create 500 milliliters of a 1 molar copper 2 nitrate solution. Team 2 will make 1 liter of a 1 molar copper 2 nitrate solution. Come up with your procedures first, and let's discuss them. Once I approve your procedures, you can make your solutions. Okay, everyone. Who's ready to present the plan that they're going to use to create their solution?
We'll give it a try. We have to make 500 milliliters of a 1 molar copper 2 nitrate solution, which means we actually need to have 0.5 moles of copper 2 nitrate dissolved in a total of 500 milliliters of solution, right?
Since molarity is the ratio of moles to 1 liter, we figured that to make a half a liter of 1 molar solution, we would need half of a mole of copper 2 nitrate.
That's right.
Looking at the molar masses from the periodic table, copper 2 nitrate has copper with a molar mass of 63.55 grams. We multiply that by 1 because there's only 1 copper in the formula. Nitrogen has a molar mass of 14.01 grams. And because copper 2 nitrate has 2 nitrogens in the formula, we multiply that by 2. And oxygen's molar mass is 16.00 grams. And we multiply that by 6 because copper 2 nitrate contains 6 oxygens in the formula. After multiplying all of those and adding them up, 1 mole of copper 2 nitrate would have a mass of 187.57 grams. So half a mole would be 93.79 grams.
So now we just add that to the flask and add about 500 milliliters of water in there.
Wait, actually, I think we just put the copper 2 nitrate in and then add water until it comes up to the 500 millimeter mark.
Oh, right, the denominator has liters of solution, not just solvent.
Yeah, the copper 2 nitrate is going to take up space, which is why we have to use this flask, I guess.
Great catch, and you're exactly right. That's why we have to create these solutions with specific types of glassware. We have to be able to account for the volume or the space that the solute is going to take up. Your team is good to go. Okay, team 2, are you ready to tell me with your plan?
I'm pretty sure we are. We need to make 1 molar solution of copper 2 nitrate, which is 1 mole of copper 2 nitrate dissolved.
Yeah, and according to the masses on the periodic table, the molar mass of copper 2 nitrate is 187.57 grams.
Exactly. So we just need to mass that out and place it into the volumetric flask, right?
And then we'll add water up to the 1 liter mark to make sure it's 1 mole per 1 liter of solution.
That sounds like a great plan. Everyone, put on your safety goggles and you can all go ahead and start creating your solutions.
Careful.
Keep it going.
How's it actually gonna be?
Yeah, I don't think we will.
Our students already described their very detailed plans for you, making your job a little bit easier. But you've still got the activity itself to do. By the way, depending on how you round off your atomic mass, your exact numbers could be a little different from those of our students. We'll take a break here. When you're done with the Molarity lab, you can compare your results with the results of our students. We'll take a look at those at the top of the next video on the playlist. I'll see you there.